To solve an equation by graphing, first, graph each side of the equation as if a separate function. And then locate points of intersection. That will give you the solutions. So in principle, it's fairly simple, but in practice, not always quite so simple, but let's do this example. So we're going to treat the left side as f of x. So we'll assign that f of x, and we'll assign the right-hand side g of x, and then graph them. So remember, we're looking for where these two functions intersect. And so here I'll be using GeoGebra to do my graphing, but you can do your graphing in whatever you choose. So there's a graph of f, and then my graph of g will look like this. And you see we have points of intersection, and GeoGebra automatically highlights them. So here's a place where they cross, and if I just click there, it tells me that the intersection point is -4.0212, etc., for the x coordinate, and -2.3866 for the y coordinate. Now it's the x coordinate we're looking for. So from here, and we'll have -4.0212. So go back here, -4.0212. So my first solution is x equals -4.0212. And that's the best we can do. We'll never get an exact answer, but we'll get some approximations. And if I click this other one, it's 3.0479 rounded off. 3.0479. And that's it. That's all we have to do, except we have to be a little bit more careful, because there's no guarantee that all the intersection points will actually show, and we can find out pretty quickly that they don't all show on the standard view. So sometimes you need to zoom in, zoom out, do a little panning, and if I click again here at the intersection, I get another one. This one's at 11.983. So let me record that one, 11.983. Here we go, 11.983. Okay, so why does that work? Let's talk about that for just a minute. Because when we're looking at our graph, every point on the graph of f is an input-output pair, x, y, and so is every point on the blue graph on g. Every point that's graphed is an input-output pair. So when they cross, that says that the two functions have the same input-output pair. In other words, for the same x, these x values, inputs, produce the same y values or outputs. So that's why it works, but there's something else that can also happen. So let's get on to a second example, and I'll show you another thing that could possibly happen. So here we have e to the x minus 2 equals the natural log of x plus 4. So I'll replace these functions with e to the x minus 2 and natural log of x plus 4. And you see, just like before, I do get one of the intersections, no problem, 1.2995. 1.2995, that's what I meant to do, 1.2995. So we have x equals 1.2995. That's one of the solutions. But there's another one here. We can clearly see it, but GeoGebra doesn't automatically find it for us. It doesn't put a point there. I can highlight either of these functions, but neither way do I get that point there. So a little bit more work to do. We use the intersect tool of GeoGebra and just click really close to there. It'll put a point, and we can go to the algebra window to find out where that is. And here it is. A is the intersection of f and g, and the x coordinate is negative 3.8618. Negative 3.8618. Negative 3.8618. And just as before, to be complete, we should at least consider whether or not there are going to be other intersections that aren't showing. And it helps if you have a sense of what the exponential function looks like, knowing that the exponential function will just go up continuously very quickly and excuse me, to the right and level out to the left, where the natural log function has a vertical asymptote here and goes up very slowly to the right. You know that it will not have any more intersection points. So these are the only two, and we have a complete solution.